Welcome, everybody, to the latest episode of Stars, Cells, and God. My name is Rana. I'm a biochemist and a Christian apologist, and today I'm joined via Zoom by Steve Anonsen, a Christian apologist, and we're going to take on the question today, did the Catholic Church in the 16th century stand in the way of scientific progress by imprisoning and persecuting Galileo? Or is there more to the story? You don't want to miss it. Hey, Steve. Thanks so much for being back with us on Star Cells and God. So good to see you again.
Likewise. It's going to be fun.
Oh, yeah. I'm really looking forward to it. You've obviously put a lot of work into this question, but let me just set the stage. I think most people are familiar with at least the popular narrative that here we have heroic Galileo, a man of science who has made observations and is now advocating for a heliocentric view of our solar system, and that this is in opposition to the church's teachings on geocentrism, and the church, it stands in the way of scientific progress, shutting Galileo down, persecuting him, putting him on trial. He spends the rest of his life in house arrest. And of course, this then becomes kind of a metaphor, or maybe an example more appropriately, for the fact that Christianity stands in the way of scientific progress and that there's this inherent conflict between science and Christianity. But you've done quite a bit of research on this question, and you're going to maybe help correct some of the popular misconceptions and help us to really understand what is the myth and the legacy of Galileo. So very much appreciate you doing that. And so we're going to get into some science, some history, philosophy, and theology. So thank you. It's going to be a wide-ranging conversation. Steve, let me open up with this question, first of all, and that is, why does the story of Galileo even matter to our listeners and to our viewers?
It matters because people today don't understand that Christianity actually contributes strongly to the scientific enterprise. And if you don't know the history, you're going to repeat errors. And we see actually some of these errors being repeated today. And as we look at a couple of quotes, we'll see this, but there was just a podcast yesterday that I was listening to, and I was in the chat on this thing, and somebody was saying, you're making claims without evidence. And I thought, oh my goodness. And that's exactly what this is about, is some people say that the church was making a claim solely based on some verses in the Bible, ignoring all other things. And it's false. It's dramatically false. So we want to understand the real history so that we can understand how we would play it out again today.
Yeah. And so you have a quote from David Mills. Did you want to read that quote to us? Because I think that's a really powerful quote that exemplifies this whole idea of a conflict model.
Yeah. So Mills says the Christian church fought bitterly throughout its history and is still fighting today to impede scientific progress. Galileo, remember, was nearly put to death by the church for constructing his telescope and discovering the moons of Jupiter. This is stunning in how incorrect it is. Galileo's work with the telescope actually made him a rock star. Mm-hmm. And there's a pun intended there. He was feted for his discoveries. He was feted by leading scientists, political figures, church luminaries. Now, people also probed his work. They said the telescope was new, right? So they probed it, and that could be frustrating to him. Yeah. But no, he was basically a big deal because of that. So the issue is this: is simplistic and inaccurate view of this event in his life just misses an exciting example of good science, and good science done by a set of brilliant Christians. including some connected to the Catholic Church, including Galileo. So instead of impeding scientific progress, Christians advanced it.
Now, you're not saying, of course, that Galileo wasn't in conflict with the Catholic Church at all, right?
No, he was. The conflict made Galileo's life pretty tough. He was put on trial, sentenced to house arrest, as you mentioned, and his books were banned. Now, the reasons for that are complex, and Galileo actually bears part of the blame. But actually, we're not going to talk about that today because it's actually not the centerpiece of the story. We'll touch on it a little bit.
Yeah.
Yeah.
Well, now, Mills, who we just read, or who you just read his statement, is a belligerent atheist. But, there's other people who aren't necessarily adopting an atheistic stance that still inaccurately describe the history of Galileo and his relationship with the church.
Yeah, that's right. You see this all over the place in popular articles, videos, books. I was just listening to some random thing that was produced by a philosophy class, and they said Galileo was notorious because he dissented against, get this, the oppressive papacy. Now, here's an irony for you. The Pope at the time, Pope 13, was a supporter of Galileo even before he was named Pope. Now, Galileo managed to alienate him, but no, the Pope was actually his fan.
Interesting.
There's another example here. The introduction to perhaps Galileo's central book on heliocentrism is dialogues concerning the two chief world systems. And guess what? Einstein actually wrote an intro to this thing. And he said in that foreword, Galileo possesses the passionate will, the intelligence, and the courage to stand up as a representative of rational thinking against the indolence of teachers in priests and scholars' garb. So you get it from some of the finest scientists as well. If you go on and read the rest of this thing, he manages to put out every myth about a bunch of stuff. He calls the things the Dark Ages and whatnot. But anyway, sorry, I am actually contesting something of Einstein's, even though I am a midget compared to him.
Yeah. Well, there we go. Okay, so Steve, maybe the place to start here is a little bit about just the whole history and what does the history tell us about really Galileo's story.
Yeah, okay, let's cover this in two parts. First, let's start with heliocentrism. This will tell the story of where the context where Galileo fit in. And given that context, we'll then narrow our focus to Galileo. And we'll talk about philosophy and the history of science, integration of science and faith, a variety of different things. One thing before we begin, an interesting tidbit is that Galileo believed in the two books of general and special revelation, that is nature and scripture. He believed they will always be consistent. And so I thought, well, he could be quoting you.
Yeah, interesting. Okay, so let's start with the history of heliocentrism, because really what's in focus here is what is the appropriate model for the solar system. And in Galileo's day, there was a different model that was really being advocated, as I understand it, by the church. So let's unpack a little bit of that history for us, Steve.
Sure. I should mention up front that this actually has scholarly consensus. I will be saying, I think, a few times, but the baseline of this is actually well supported. So here's the first thing, and perhaps the primary thing. It took 150 years for Aristotle's geocentrism to be replaced by heliocentrism. And so it was a journey starting with Copernicus and ending with Isaac Newton. And by the way, they used the Bible and theology all the way through as one line of argumentation. But they didn't stop there. Mathematics, observation, philosophy, beyond theology, these all played a role. Now, there's a slide I have here, which shows the timeline that we'll be going through briefly here. What you'll see on the left-hand side, these are the pieces that make up the viewpoints. So Aristotle set a towering physics before people. And there were three different systems that were brought about: Ptolemy, Copernicus, Tycho, and Kepler actually refined on Copernicus. We'll be talking about each of these. Perhaps the interesting thing to note is the dates. I didn't know what the overlap was between these people, and it was a little surprising to me. Galileo then built on top of this. So we'll then switch to Galileo, another fellow nobody knows about, Riccoli, but he's a fantastic scientist, and with Newton. So let's go. We can move on to Aristotle if you're ready.
Sure. Yeah, sure thing. So Aristotle's at the beginning. So then, what was his model, and was this a model that the Catholic Church embraced?
His cosmology and physics, they were the nearly universal understanding. We should just call it universal. And it prevailed for 1700 years. Mm-hmm. It's dramatically different from my understanding. So let's look at some major features. We can switch to the next slide. And what you'll see here is the Earth at the center of a set of spheres. And in his model, the spheres were transparent, hard spheres that would rotate. Now, the heavens in his model were very different from the Earth. So the heavens, they were perfect, they were eternal, they were unchanging, and they're made of a different element than the Earth. And their motion actually functions differently as well. So there's two pieces. There's this heliocentrism, but the motion is very important because that's the physics that's involved. And we need to look at both of these. Now, the Earth was made of fire, water, air, and earth. And those were the elements. And the way that worked is that each element had its own bias to move in a particular way. And the Earth was corruptible. So you have this corruptible Earth with motion driven by the elements, and then you have the heavens with these spheres.
Okay, so then this was then the Catholic Church's view. Is that correct?
Yeah. Now, we should note that Aristotle's cosmology was not developed by the church, and it does not appear in the Bible. However, since it was accepted by everybody at the time, you had theologians like Thomas Aquinas who integrated Aristotle's views in Christian theology, which required modifying Aristotle. So really, we could say here the church was following the science, just like today we've got the church who are accepting Kepler and Newton's work. Now, there are some passages in the Bible that suggest the earth is immobile at the center of the universe, which is Aristotle's view. And that actually became a dogma of the church. Now, it wasn't a dogma of church just because of the verses. It was concluded based on conversation with scientists, and it resulted with Galileo's view being formally rejected. Now, we should note here, though, the church wasn't unyielding on this thing. There's a guy who was consultant to the Inquisition, which, by the way, is the group that put him on trial. And he said the church is willing to reinterpret scripture should the science call for it, but not before. So unless the science changed, the church's theology concerning planetary motion wasn't going to change. And as we will see, the science was not settled. So we'll return briefly to the trial later.
Okay, and so I think this is an important point, because what you're saying is that the church was reading these scriptural passages in light of what was the prevailing scientific view of that time, saying, look, if this is the prevailing view, then these scriptural passages seem to be in alignment with it, seem to harmonize with it, but that they were completely flexible, that if the science changed, it would suggest to them that maybe that original interpretation may not be valid. I think that's a really important point. Am I understanding that correctly, Steve?
Yes, that's right. I'm sure there'd be some who would object to this, but my point is a guy connected to the Inquisition who was very highly regarded made this statement.
Yeah.
So it's pretty interesting. So the myth says the church was opposed to Copernicus purely based on theology. But here's the thing, there were three different models, not Copernicus and Ptolemy. Many people don't even know who Ptolemy is. Not just those two, but there was a third one that was out there, and these were competing models for planetary motion. So Ptolemy, Copernicus, and the third one was by a guy named Tycho Brahe, and we saw his name in the timeline. That Copernican view didn't become the consensus view over Ptolemy and Tycho until after Galileo died.
And I think this is something that was an aha moment to me when I was reading through some of your notes that you provided me ahead of time, is that uh, there wasn't like this open and shut case for Copernicus's view and for heliocentrism. This was an area that was intensely being debated, and people were proposing models and alternative models trying to make sense of how we understand our solar system and the universe.
Yeah, that's right. I mean, it's a scientific process at work. You have people bouncing ideas, objecting to the science, being mean to each other for, jealous reasons. Who knows? There's all these things that go on. We see it today in scientific
Yeah.
circles.
Okay, so then maybe it might be worthwhile kind of stepping through these models and spending a little bit of time understanding the models and what were their strengths and limitations. So let's start with the Ptolemaic model. Unpack that for us.
Okay, yeah. Claudius Ptolemy wrote his book describing his model in the second century, about 150. By the way, this model prevailed for 14 centuries, and it remained consensus view long beyond 1543 when Copernicus published his book on this, on the revolutions of the heavenly spheres. So what he was trying to accomplish and succeeded accomplishing is a technical method to predict the motion of the planets. And it's not hard to see that this is a tool of practical value. They would use it for agriculture, astrology. It's how you'd set the date of the spring solstice. You knew when Easter was. So the goal was to explain the phenomena. It wasn't to develop a model of the cosmos. And in fact, what Ptolemy did is he just took Aristotle's model. So around 150, as I said, he published a book called Almagest, 13 volumes, wildly successful as a tour de force that gave an effective technique for predicting planetary motions. It was also, as I say, tremendously long-lived. Now, the frame of reference for this was Earth. And if you get to Copernicus, the frame of reference switches to the sun and a somewhat omniscient view. Now, there's a complicating factor that he had to account for, and his predecessors hadn't done yet, which is the planets sometimes move backwards in the sky. They call that retrograde motion. And the second thing is their velocity isn't constant. So Ptolemy needed to be able to account for paths as diverse as what you'll see in this next slide. So how in the world do you come up with a system that can follow that tracing back and forth in the sky? Okay, so as I say, the calculations, we're going to go to the next slide, and this is going to show the elements of his view. And what you're going to see there is something interesting. You see the Earth down there, and you see an X right above it. Calculations actually weren't centered on the Earth. They were centered on a point outside of the Earth. And what you see is a dashed line, and that's called the deferent. And that was the centerpiece of motion. To actually track the planets, though, they planted something on top of that dashed line called an epicycle. So this is the second dashed line. And then the planets moved around on that epicycle. So what you had is these various different elements. There's a third element we should talk about here, which is the dot that sits above the X. That was called the equant. Now, what it did is I said that velocity was inconsistent. If you calculated velocity from that point, it actually swept the sky with the same angular velocity. So he managed to pull off actually getting the velocity figured out by sticking that little dot in there. So even if you don't catch the details of this, and I just brushed over it quickly, you can see the system is complicated. The thing to remember here is it actually worked really well. It calculated the positions of the planets really well. Um, and here's an interesting point. It still works today. It isn't tied to Aristotelian physics. And in fact, this sort of view is what's used in planetariums, right? Because a planetarium has to sit on Earth, and you see the stars with reference to the Earth. It's just the Aristotelian physics was sitting there.
Right. Right. So even if there wasn't Aristotelian physics, then in other words, the Ptolemaic model would still be something that you could reasonably think someone would develop, because if the frame of reference for observers looking to the night sky is the Earth, of course you would develop a system that would be geocentric in that sense. So in terms of understanding what the purpose of the model was, what he did makes perfect and reasonable sense.
Mm-hmm. That's right. That's right.
Okay, so then what about the Copernican system in what kind of initiated this alternate model, 1400 years, into the existence of the Ptolemaic model?
Well, one of Copernicus's objectives was to come up with a system that was centered on the sun. And so, in part, his interest was actually to do exactly the same thing as Ptolemy did. That's one piece of it. So he developed what seems like a straightforward system for planetary motion. And why don't we go ahead and move to the next slide? And it wasn't a new idea. It had been kicked around for quite a while, but Copernicus basically formalized it, or, put together the math so it could be used to calculate planetary motion.
So he had, again, the same objective, and he was hoping for maybe a simpler model or a simpler system that wouldn't be as complex as the Ptolemaic system.
Well, perhaps. He wanted the sun at the center. I'm not exactly sure what his objectives were beyond being able to pull off what Ptolemy did. We know in retrospect that transition was going to affect us all the way to today. Now, if you look at this picture, then what you see is Sol is at the middle there, Sol being the sun, and then you have the planets moving out from there. So simple, right? Well, the thing is, Copernicus did this in circles. So if we move to the next slide, circles are wrong. Copernicus was just flat wrong. So what he had to do, and by wrong, I don't mean the calculations that he did. I mean in terms of matching what the universe looks like.
Right.
So he ended up having to put together a bunch of epicycles as well. And the number of them was less than Ptolemy, but honestly, there was probably 50 of them, I would say.
Mm.
So it was pretty complex. It didn't necessarily make calculations better. It didn't make things more accurate. In some cases, what he was doing is more so, and Ptolemy was ahead in other things. An interesting thing is he wasn't really an observational astronomer either. He didn't bring new evidence to bear on this, but he was brilliant in producing this mathematical system. One thing that is true, though, this system is simpler because, for example, with Ptolemy, he had different models for each of the planets, and this Copernican model was actually the same for them. So there's much we can say about how this will eventually really be a profound impact. But at this very moment, right? Let's just use the history at that very moment. This is the benefit that he brought about.
And again, what was that benefit? It was just a simpler model.
That's what proved to be the case.
Yeah.
That's what proved to be the case. And there's reasons to think. Let's just take this: the entire universe is circling around the Earth. That seems like a lot of substance and weight.
Right.
To be circling around the Earth. And it kind of, people went, But that's a philosophical argument, right? And there were certainly a lot of those out there, and they're not decisive.
Right. Right. Okay. So, and still we consider Copernicus kind of the father of modern cosmology. So, how do we reconcile what you're saying with that status that Copernicus has?
Well, the thing to realize is that his system actually had a big influence on scientists of the day, just a handful of them. Uh, his book on the revolutions, it was really technical. So there's not very many who can understand it, which by the way helps him avoid people who are going to criticize it on other grounds. Um, his views were heavily criticized. They were criticized on theological and scientific grounds. Now, this shouldn't surprise us. I mean, he was bucking up against
Yeah.
well over a millennium of history, and he didn't really have uh, new evidence. And so it's not surprising that he didn't win adherents in his lifetime.
Yeah.
Look, the same thing happened with like plate tectonics. That was a much shorter time frame, but people looked at it and said, huh, no way.
Yeah.
And in time, it shifted.
Okay. So, what we're describing here really is good science at work, even, in with respect to how people were beginning to wrestle through the whole issue of what is the proper model for our solar system.
Yeah, that's right. And, it takes time. That's good science. Um, Thomas Kuhn, in his Structure of Scientific Revolutions, talks about this idea of a paradigm shift. And that's what was happening. But the thing with the paradigm shift is it takes time. And then suddenly there's a snap and you switch to the new system. And so what I would say Copernicus was doing is he was creating pressure that would put weight on the system until it snapped over.
Yeah. So, you're in no way really then diminishing Copernicus's accomplishments or his influence on science by pointing out that his model didn't necessarily win the day.
No, that's right. The thing is, he wasn't right, but he did kickstart some things. Perhaps my point on him is don't give him too much credit because there was a lot of other stuff going on, and if you miss that, you actually miss an exciting part of the story.
Yeah. Now, there's another model out there. This is Tycho Brahe's model. I think I'm pronouncing that correctly, Brahe. And I am familiar with him as an astronomer, but I didn't realize that he had actually a model for the solar system as well that was kind of a hybrid, I guess.
Yeah, that's exactly right. A quote, by the way, I argued that I didn't have to argue. It's true that these guys were Christians. I like this quote from Tycho: "Those who study the stars have God for a teacher." Isn't that cool?
Yeah, yeah.
So Tycho's an interesting guy. He got into a duel with his cousin because they disagreed about math and there was alcohol involved. Well, he got his nose cut off. So he ended up creating these noses, and if you go to nice events, it would be a gold one that he stuck and glued onto his face. So what a character. He had a pet moose. He had a dwarf jester, just a very curious fellow. First thing to know about the guy, though, is he was unquestionably the greatest observational astronomer in that day. And, people talk about Galileo's observations, trivial compared to what Tycho did. He invented instruments, he invented techniques. He'd stick instruments underground to isolate them from environmental influence. He actually did further the telescope later on, by the way, but it didn't really become significant until after he died. Now, I have a picture here of his observatory, and he ended up with a patron in the Danish royalty. Probably 1% of the Danish national product was spent on building this thing. It's called Uraniborg, or Castle of the Heavens. And it was actually a research center. Now, Tycho found evidence here against Ptolemy's system, and he used his stellar observational skills to do this. A bit later, Galileo actually found other holes in Ptolemy, and it'd perhaps be better to say Aristotle.
Yeah.
So I'll give you some examples here of this. So Aristotle said the heavens were unchanging. So contrary examples, one is something that's now called Tycho's star, and it was a supernova seen in 1572.
Mm.
Now, you shouldn't have new stars showing up if the heavens are unchanging. And the
Right.
second thing he did is he studied a comet of 1577, by the way, with greater detail than anybody else had done by a good measure. He also determined that it sits past the moon. Now, the moon and beyond was not supposed to be changing, and here's this comet floating around in the sky. So it was a pretty significant issue. He had to also convince people that it wasn't atmospheric phenomena. It
Mm.
really was a real body, and he managed to pull that off. Now, to show you again how scientific progress works, Galileo, maybe 40 years later, argued that it was atmospheric phenomena. So it took time for that consensus to come about as well.
Okay, so then Tycho is a great astronomer, but what were his views on planetary motion then?
Uh, it's it's actually really simple, and we'll look at the next slide for this. Tycho combined two different systems. So what you'll see on this picture is you see the sun and you see the planets revolving around the sun. And you see on the outside, you have the stars on their shells. The difference is the sun, as seen there, rotates around the Earth. So what you basically had was largely the Copernican model, but the Earth was still at the center of it all. And so this has been called geo-heliocentrism.
And did it have advantages over the Ptolemaic model and the Copernican model?
Well, it's believed that the Tychonic system is actually mathematically equivalent to the Copernican system. The difference, of course, is the frame of reference. Now, Copernicus did have the ability to predict stellar parallax, which wasn't actually observed until the 19th century, but that was a testable
Mm.
statement that he had put forth. But the Tychonic system actually had more adherents than Copernicus for a good while after Copernicus, and in fact after Galileo.
Yeah,
So those are the three models:
yeah.
Tycho, Ptolemy, and Copernicus.
Now, this may be an unfair question because I'm asking you to speculate about history, but do you think maybe part of the appeal of Tycho's model was just simply his notoriety as an observational astronomer and the influence that he had with regard to the Dutch government?
Um, yeah, here's what. Yeah, he was very highly regarded. Uh, for the Danish government to give him this money was really interesting. I think another very important factor, though, is he didn't change a very important part of the system. The Earth was still sitting at the center,
Mm.
so it uh, he was highly regarded, and he didn't change the system too much.
Yeah, I
Those two things are definitely uh, going to work in his favor.
yeah. So his model is much less radical than the Copernican model, then in that sense.
Yeah, exactly, exactly.
Okay. All right. Well, now we're at the point that everybody is waiting for, and that is, what about Galileo? What were his scientific contributions?
Okay, yeah. So let's take a look at the next slide. This is just to again check where we are in this conversation. We've just covered the left-hand side, which is three different systems. Yes, we're going to now go to Galileo and talk about some of his accomplishments and some people who followed him. So let's start with the telescope. Oh my gosh, it wasn't a thing in his day, but he refined it dramatically, ended up with something that was like about a 20x
Mm.
telescope today. So that was revolutionary. And he did it by actually making his own telescopes. He ground his own glass, he refined the mechanics of the things. So it was pretty surprising. But what he found with this was a challenge to the Ptolemaic system. So a few of his discoveries. He discovered that Venus has phases. Now, what do phases means? Phases happen when a body rotates around the sun. So that was a challenge. Second, he found that the moon's surface is actually rough. Now, the moon's surface is supposed to be perfectly smooth in the Aristotelian system. He also found out that Jupiter had 4 moons. Now, you may remember that Mills actually talked about Jupiter's four moons. Those objects didn't revolve around the Earth, which is suspect on the Aristotelian system. So, as I mentioned, far from nearly being put to death, he did become a rock star from this, and he really was very highly regarded because of this. Now, it's worth pointing out the telescope wasn't actually immediately accepted. It was really the degree to which he had created it was a new instrument. So once again, people wanted to eliminate possible issues with it. Again, part of the scientific process. So they wanted to know, well, is it aberration because of the lens? They hadn't actually seen through the telescope because there weren't instruments of his quality. So he had to run around with his telescope so people can look at it. And he built a bunch of telescopes and sent them to luminaries of his time. But how many telescopes can you build, right? So people just didn't have the ability to accept this. And it frustrated him. It really frustrated him. It's obvious. Why don't you just take my word for it?
Yeah. Well, and that's not the way science works, though, right?
Right. Exactly.
Yeah. Okay. So, I mean, so then his work with the telescope proved Copernicus right. Is that correct?
No. We look up the Tychonic system addressed all these issues. It addressed all the weaknesses that that Galileo found with the telescope. It addressed the weaknesses with the comet and the nova that Tycho found. So they were, in terms of these issues, basically equivalent.
I see.
The difference was whether the Earth revolved around the sun or the other way around. Now, it's interesting, Galileo didn't take Tycho seriously. And I mentioned his key book, Defending Heliocentrism. Listen carefully to this. Dialogue concerning the 2 chief world systems, Ptolemaic and Copernican. So he attacks Aristotle and Ptolemy, but ignores Tycho, which was the greatest competitor, and it was the greatest competitor beyond his lifetime. So he didn't take him seriously. So while that particular book is an important response to Ptolemy, without more evidence, it couldn't be a decisive argument for Copernicus. So it does not prove Copernicus right, but it does weaken Ptolemy, and that is suggestive. Okay, now you've got 2 options instead of 3. So it did some good work in that respect.
Okay, so now perhaps Galileo's most important work is the book called The 2 New Sciences. And so what is that book about?
Well, it doesn't have anything to do with telescopes, really. Galileo did a bunch of experiments before he got into the heliocentrism and the telescope, and it was concerning physics. Now, the thing we have to realize is that for Aristotle to be supplanted by some other system, you need a new physics. It's fine that you can create another system, but how does motion work in the world, for example? So 2 New Sciences made really important strides toward a new physics, and he worked on dynamics, which is the theory of motion, plus many other pieces. And to truly confirm Copernicus, that physics was needed. And there's more that will happen with Kepler and Newton, which we'll talk about in a minute.
All right. So now, what was the church's reaction to what Galileo had done, right? Because this is now where the conflict between Galileo and the church comes into play.
Yeah, it's important to say a few words about it, even though it's not the centerpiece. And it's just, these are just to give some context to what was going on. First of all, the 1633 trial did not discuss the merits of heliocentrism,
Mm.
which a lot of people don't realize. The focus was Galileo made an agreement like 1616 or so to not teach heliocentrism as a fact, but he went ahead and did it anyway.
Now, he could teach it, he just couldn't teach it as the explanation, right, or the model.
That's exactly right. What you could do, and this was fine with the church, is you could teach it as a possibility, but not as a fact. Now, philosophers of science today would call that anti-realism, specifically instrumentalism. So the idea behind this is you may not be actually modeling the real universe, but you have something that actually helps you with calculations. And actually, this is the current story with quantum mechanics, because there's this thing called the wave function and it collapses, but it's this probability thing, and you've got all these different interpretations of it, but it works fantastically. And so he certainly could have done this, but he was interested in what's really out there, and he just felt he needed to teach that. Another thing to include here is rejection of heliocentrism wasn't just a doctrinal issue. And I mentioned this before, you have these specialists in a variety of different fields. So around 1616, they forbade heliocentrism be taught as a fact. And they talked to a variety of people before they came up with that conclusion. You know, another thing to keep in mind here, and we'll talk about this a little later, is Galileo was really arrogant and he was belligerent. He ignored the advice of friends who said, just, you can soften this whole conversation and make it go easier. So here's a statement that came out of the trial. It's by a guy named Father Grassi. It says this. I think we have a slide on this as well, so people can see it since it's a longer quote. I have always had more love for Galileo than he has for me. And by the way, Grassi had been in scientific conflict with Galileo, especially on comets. He says that in last year in Rome, during the trial, when I was requested to give my opinions on his book on the motion of the earth, I took the utmost care to allay minds harshly disposed toward him and to render them open to the conviction of the strength of his arguments. The trial wasn't a situation of, the world against Galileo. He had advocates there. But then Grassi observed something. He said, he has ruined himself by being so much in love with his own genius and by having no respect for others. One should not wonder that everybody conspires to damn him. And he did have a lot of people who chafed at him. Now, this is the view of one person. You're going to get other views from others. But my point is that, this arrogance definitely affected people who were even his supporters.
Okay, let's see here. So now we're moving on to Kepler, right? This is the point in the story where we're now going to start bringing into play physics that will actually support the Copernican model.
Right. There are two pieces to what Kepler provided. First of all, Kepler was a big fan of Copernicus, and so he was attempting to produce a system that furthered his theory and addressed issues with Copernicus. And we've heard this story before, but what he did is he used Tycho Brahe's data. He actually worked for Tycho for a year. He used that data to help him look at Mars and figure out that it had an elliptical orbit, not a circular orbit, which is pretty profound thing. And in fact, he produced laws of motions from this that are taught in classrooms today, unchanged. So it was to me, I look at Kepler, and I'm a Kepler fan. I think Copernicus deserves a lot of praise, but Kepler, man, he came up with something lasting. Now, unfortunately, people like Galileo and Descartes ignored Kepler's theory.
Mm.
Um, Kepler, interestingly enough, though, he had a friendly relationship with Galileo, and he actually advanced his work on the telescope. The guy ended up being called the father of modern optics as a result. But a lot of his work was mathematical. He used somebody else's observational data. And by the way, his the heirs of Tycho didn't want Kepler to use his data because of basically copyright.
Okay.
So he couldn't publish his work for a few years until he got, effectively permission to do so, which was pretty amusing.
Yeah. Yeah. Human nature, right? Okay, so now what about Riccoli?
Yeah, Ricoli's a curious guy. As I say, many people have never heard, most people have never heard of him, and those who talk about him tend to be pretty down on him. But he did something remarkable in 1651. Now, that is 2 decades after Galileo died, okay? Keep that in mind. He was a Jesuit, which is a Catholic astronomer, and he published this book called New Almagest. Now, you may remember that Almagest was the name of Ptolemy's
Mm.
major groundbreaking work. It was a 1,500-page work. It became a standard reference work all over Europe. Now, it opens with a comprehensive review of astronomy at the time. And this is part of the reason why it became a textbook. It also looked at 126 arguments for and against Copernicus and Tycho. Some of them were great. Some of them were just for completeness because they were silly. But he ends up concluding that the evidence is in favor of the Tychonic system on scientific grounds. This is 1651, 20 years after Galileo.
Now, I would not have expected that at all. I mean, because again, you have this impression, right, that heliocentrism is, true, and therefore everything would line up against it, or line up, sorry, for it. Okay, so why did he fail, and what can we learn from the letter?
Well, here's the interesting thing. He focused on theology and biblical interpretation, but he didn't present the evidence that supported Copernicus. So
Mm.
let's say that somebody was sympathetic. Um, they thought, okay, I'm at least willing to look at your views here on theology. By the way, the theologians wouldn't think much of a scientist pontificating on theology, but set that aside. He didn't do that. In fact, he insulted people in his letter. Uh, so great, you don't agree with me, therefore you're a bit stupid. Um, we should look at a couple opening matters because I just mentioned that he was a little abrasive here. And so let's talk about getting the full story. Here's an important thing to note. You can't understand all of the issues by reading just Galileo.
Mm.
Not at all. He has a very strong viewpoint on a lot of things. And we see this with a variety of people. He uses some straw man. And there's a sniff test you can use for this, which is, what do you think his opponents really believed? Did they ignore the evidence of their eyes and their instruments, which is, by the way, what Galilei was arguing in this letter? It's not credible. Who's going to ignore what's in their face, right? So there's a bit of a straw man there. Now, he didn't fairly represent their views. They couldn't possibly have been as thick-headed as he said. And so he attributed motives to them that weren't clear at all. He couldn't read into their head. There's a lot of ad hominem there. And again, he skipped some stuff. He skipped Tycho. He skipped elliptical orbits. This stuff was known at the time.
Mm-hmm.
And he actually overstated Copernicus's status. And I'm not saying this was malicious in any way. How would he know actually where these things were at? There's a variety of different pieces of this. But one example is, he said people all over were reading Copernicus's work. His work was very technical. People could not have been reading it. They wouldn't have understood it. Very few people could understand it, people like Kepler. And he said that, oh, everyone's okay with it. Well, no, there was a lot of negative views on this. So he was a tough guy to get along with in this respect. And he was, I could see how the people who were listening to him might have had some issues with this. Let's move on to a second interesting point before we get into actually the theology. He does ask people to prove a negative. So let me give you this quote. Before a physical proposition is condemned, it must be shown to be not rigorously demonstrated. It must be shown by those who judge it to be false. Now, how in the world are you going to prove that?
Yeah.
That means that, well, any possibility that could ever happen, you have to account for that. Because if you don't, something new may come up. So somebody who makes a claim is the one who actually has to demonstrate it. By the way, Darwin pulled the same trick. It could, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, how are you going to know which things could possibly falsify that? So those are just a couple opening points, but our closing topic is this boundary between nature and scripture. And I think that's the heart of his views that we want to look at here. So let's start with the philosophy of science. He's praised for not wanting science to be constrained by authority. At least that's the way people read him.
Yeah.
And here's an example. Nothing physical which sense experience sets before our eyes ought to be called in question, much less condemned upon the testimony of biblical passages. Well, that's only if the evidence is clear. That's only if the evidence is clear. In most cases, the evidence isn't clear. That's true today. We've got bias, we've got incomplete evidence, we've got different interpretations of the evidence, we have the need to have others validate what we've done. And all right, so here's this guy that says, oh, the physical evidence, the physical evidence. He had his views on tides wrong. He had his views on comets wrong. The evidence for heliocentrism was incomplete. So there's definitely some truth in what he had to say there.
Right.
But it's not always obvious just what the science actually says. And once it's settled, yeah, you need to take that into account, but not just this idea of no matter what it is, get the scriptures out of the way. So another piece here is the boundary between authorities. And the two authorities that I'm referring to is the authority of scripture and the authority of nature. This is the two books view. And interestingly, he actually affirmed inerrancy. And he affirmed that those two books are always going to agree if you understand them right. Totally standard view that exists today. Contested, but standard view. What he did, though, is rather than focus on the verses on geocentrism, and these were the ones that were giving him trouble, he wants to limit Scripture to salvation. He wants to give it a different role. He wants to give it what I'll call a diminished role. So his goal was to promote Copernicus without interference from censors. And his approach was actually to deny Scripture the authority to speak about the book of nature. And he got unintended results because of this. But let me give this quote. The primary purpose of the sacred writings is the service of God and the salvation of souls. And then he gets this quote, teach us how the intention of the Holy Ghost is to teach us how one goes to heaven, not how the heavens go.
Right.
Which actually I don't buy.
Yeah.
I don't think that's right.
I mean, and that sounds very similar to the classic essay by Stephen Jay Gould on the two magisteria, science and science and scripture. Really, they represent two completely distinct domains of knowledge. So on one hand, Galileo is saying things that we would resonate with here at Reasons to Believe, right?
Absolutely.
But then on the other hand, he's saying things that we would be very uncomfortable with, that sound much more like Stephen Jay Gould than they do Hugh Ross, right?
Well, and that means that Galileo would have been uncomfortable with it as well.
Yeah.
Now, another piece of this is he calls the verses on geocentrism accommodation. People were too unsophisticated to possibly understand these things. It's all accommodation. Now, the last talk you and I had, we talked about hermeneutics.
Yeah.
So how do we know when accommodation is being used? That's done by good biblical interpretation. In fact, in the last talk, I talked about the earth being unmovable and how to exegete that. So that's, rather than just brushing it away, we need to exegete it. Another thing that he said is if errors occur in interpretation of the Bible, you can't use the Bible on physical matters at all. Well, that's, again, doesn't make any sense. So let's talk about what maybe a better view of these questions are. And this is seen in his comments on theology being the queen of the sciences. Theology being the queen of the sciences, which was the view at the time. Now, he suggests some meanings of this, both of which were wrong, by the way. He said that, well, it could mean that theology overrides what's obvious to the senses. Red flag. It would be silly for somebody to suggest otherwise. So that's a straw man. But he said theology is limited to the sublime. And he spins this. I'm going to call it spinning. He spins this because who on earth is ever going to believe that the senses don't have anything to do with it? So what does this theology as a queen of the sciences means? Well, theology is the umbrella over the other disciplines. It integrates them as part of God's truth. You've got creation, you've got humanity, you've got the fall. Creation, of course, being a critical element to this. You could call it a worldview issue, right? And in fact, theology and scripture do dramatically affect our interpretation of nature, and in fact must do so. And I'll give some quick examples here. You've got Adam and Eve as the progenitors and source of original sin. You've got an absolute beginning to the universe. You've got people with a completely different view on this, like, say, a materialist. If you put these things before Galileo, his assumption was the Christian worldview. He worked within that framework. So this idea that his views could be used to eliminate Christianity would have been horrific to him.
Yeah.
Which is why I say I think that he had unintended consequences, and we can look at his comments with that in view. And remember that God made the world intelligible to those who are made in his image. You know, the Greeks saw the world as chaotic. Why bother study it? And so Galileo's very ability to read nature is explained in the Bible.
Okay, Steve. Well, so this is just really quite interesting here because I've learned quite a bit that I didn't know about the history of heliocentrism, and it really, I think, helps us to put Galileo into the proper historical context, and also his conflict with the church. And so it seems to me like, you know, what you're arguing here is that the church actively was encouraging good science and good scientific discourse, while at the same time taking a stance in which they saw themselves protecting orthodoxy, but in such a way that wasn't stifling scientific debate or wasn't closed-minded to what was happening in science.
Well, an interesting point here is that the church wasn't the only ones who were doing this. It was a common line of argument, not the only argument, for a lot of people all over the place. Yeah, so I will say that the church made some significant mistakes. I will say that they blocked some good investigation. But as you see here, in the end, it really wasn't a big deal. It was a big deal to Galileo. It was a big deal to some other folks. But we got to the heliocentrism we believe in today without the church creating ultimate problems for the venture.
Yeah. Okay, Steve, is there anything else that you would want us to be aware of before we bring this whole thing to a close?
Yeah, well, let me just restate. We have this history of heliocentrism that's 150 years. So you have this community producing this, and that's just the way science works. People produce ideas, they disagree with each other, they refine each other's ideas. That's exactly what happened here, 150 years, culminating with Newton, whose ideas are taught today just as Kepler's. The other thing is, maybe scientists don't always fully appreciate what happens if they get into the philosophy of science, the history of science, theology. It takes some careful thinking there. And we can learn some lessons as people do that. And by the way, the same thing would be true of me. If I were to write stuff like this, you could poke holes at it. But Galileo is a fantastic scientist. He was a fantastic Christian. And we should praise him for his successes, but not be afraid to learn from him and not to put him on too high of a pedestal.
Yeah, it's just a fascinating journey that you've taken us on, and I very much appreciate that. And it's also dangerous too, I think, to take what we understand to be true today, based on a preponderance of evidence, based on robust physics, and read back into history, heroes and villains in light of what we know today.
That's right. That's absolutely right.
Well, Steve, I so much appreciate you coming back on Star Cells and God. Love to have you back on again. You've taken us into a place where we wouldn't normally go, so I very much appreciate that a whole lot. This has been, to me, a fascinating conversation. And hopefully it's a fascinating conversation for all of you who are joining us today on Star Cells and God. Would love for you to take part in the discussion about this topic for today's program in the comments section below. And remember to like the video, to subscribe for more content, New episodes of Star Cells and God release every Wednesday and are available here on YouTube and your favorite podcast app. Make sure you share this video with a friend and take note, the more we know about science, the more we have reasons to believe in the triune God of the Bible.